instances of one class. Just like you can have many houses of one blueprint. Now, here's another interesting thing about this, which we'll go into more detail as we actually start coding. You know, when we start coding, we're going to actually see all these in action, and it'll be cool. Now, when you create an object, okay, now listen up, okay, guys? You can code later. You can code later. This is, you know, I'm going to talk about the distinction between instance variables and class variables. Is everybody, if you're familiar, if you already know what the difference is between instance variables and class variables, feel free to keep coding away on your laptop. You don't have to listen to me. But if you don't know already what the difference is between an instance variable and a class variable, sometimes a class variable is also called a static variable, right? Now, I'd like to gravitate away from using the word static for a class variable. Although you'll see in C++ and even in Java, you use the keyword static to name a static variable, right? But there's a subtle difference between a real static variable and a class variable that we'll get into when we get into the implementation details, right? The subtle differences in C and languages like C, you know, like C++, you can have a static variable that's not attached to a class. You can have, you know, a global level static variable. Or you can have a static variable within a file or within a function and so on. So static in those places restricts the scope of the variable, where the variable is visible, where it can be modified, and where it can be accessed and so on and so forth, right? So you can use the keyword static. I think when class variables first came about, the designers thought, well, you know, class variables are very much like static variables because they're variables that are not, they're kind of global, right? Everybody can access these variables. All the instances can access the same variable. But we don't want the variable to be visible everywhere. So we'll just put it inside of a namespace, inside of a context. And they stuck it inside the class. And so statics inside a class came to be class variables. But that subtle difference, I don't know. It'll take a little while to understand exactly what the difference is. So, but there is a difference. For the purposes of what we're going to do today, we just need to understand the difference between what is called a class variable, or a static variable synonymously now, and an instance variable. Okay, so I'll give you an example, and this is exactly what we'll do in class, in the implementation. And we'll go back to this blueprint house example, okay? So I got this, you know, phenomenal architect who could build a building out of pure glass, right? In fact, glasses with no edges. Right? Even if you go to the Apple campus, the main building, you know, they have this beautiful building made of glass, but even there you can see these seams, right? Because they have to have these glasses that are, you know, butted up against each other. And so the junction between two plates of glass, you can still see it. But I believe, I don't know, I may be completely wrong, but I think Steve Jobs had a vision of a glass building in which there are no seams, right? Like this new iPhone, entirely made of glass. It's a complete bubble, a glass bubble, and all of the infrastructure lives inside of it, right? And you can put it in water, you can, you know, dunk it in your tea and nothing happens because there's no holes. And the Apple building is like that. All secrets, all the innovation stays inside until you release it. So it's a glass bubble. So I think, so if you have an architect like that, and you commission that person to come in and build your home, and say, I want this, right? And they say, right, here's a blueprint. Here's how you would build it. I had a dream in which I envisioned this is how the building should look, your house, or your home. And it's, right, they come up with this blueprint and give it to you. And they say, well, and pictures, right? And you go into your computer and simulate it, walk around, and everything is very nice and hunky-dory. And you say, all right, I want to build this. And you commission the best builder you can find and say, here's a blueprint drawn up by this, you know, divine architect. And you go and build it for me, okay? You've done that. Now, the architect would have said, you know, in this glass building, I'm going to have switches and thermostats placed in various places, so it's all completely climate controlled, and you have a greenhouse in this corner, you know, like the Amazon globe in Seattle, right? So they do these things, except that, you know, they have to place these in very specific areas because, you know, An architect has a vision, right? They don't even want these little things to be exposed in random places. So they say this is exactly where it needs to go, right? So micro details. So they do that, and the builder comes in and says, okay, I'm going to build according to this, and you know, they're great people are always differential to each other, right? So the builder says he's a great builder, but you know, oh, she's a great architect. So you know, I'm going to follow the architect's instructions to the detail, right? To the minute details. You know, you'll find that, you know, and I think I was mentioning this in class yesterday in a different class, is that when we start out as programmers, or builders, right, even builders, any builder, right, whether it's building a program, whether you're building a house, initially we always have, you know, a sense of pride and greatness and ambition, and we say, I'm going to go out there and conquer the world. I'm going to find the best way to do this, and everybody else has done something before. That's going to go pale into insignificance compared to my achievement, right? Everybody else is going to say, this is the standard from now. So we go in thinking that's what we're going to do. We're going to change the world, right? But I think, you know, with time, what we discover is that the only way you change the world is by putting in an additional change. You know, there's a lot of people that have made great changes to the world, and the only way you can change it is by standing on their shoulders. You can't change the world by standing on the floor, right? On the ground. You can't do that. So in order to change the world, you got to stand on the shoulders of giants, right? And giants are people who've been there and done it in the best possible way that was known to them or known to mankind for ages before. They've done it, erected incredible citadels of achievement, right? They've done that, and you want to do something better than that, right? You want to be known, you know, and so Newton, right? Isaac Newton, and what did he say? I've achieved greatness only because I've stood on the shoulders of giants, right? And then if you want to stand on the shoulder of a giant, and you're this puny little ant, right, who wants to stand on the shoulder of a giant, you can't go in and say, hey, giant, you know, I'm going to create something that's going to be, you know, you're going to be history from now on. From tomorrow, people are not going to talk about you. People are going to talk about me because what I'm going to do is going to make yours shit pale into insignificance, right? Take my little ant body and put it on your shoulder or your head, because from your head I can see much further than what you can see, because that's higher than your eye level. So I can see what people want, and then I can build something, right? So the giant will say, hey, you know, who the fuck are you going to be talking to you like that? I'm going to squish you like that. Bam, you're dead. Okay, so that never happens in real life. But that's not the reason why you want to do that, right? Because what happens is that, fortunately, as you marinate in the sauce of anything you're trying to achieve, whether it's programming or acting or writing, whatever, you tend to look at what other people have done, right? And you say, well, you know, I toiled for tens of hundreds of hours trying to understand this problem before I can craft a solution for it, right? Never mind the most efficient or the most elegant solution, right? You tell me, I want to just solve this problem, and use toil for years or, you know, months, whatever, trying to solve it. And then you see that, you know, someone somewhere 50 years ago has solved exactly this problem. And not only that, they've done it in a beautiful way, right? So you look at that and you say, well, I could not have done a better job than that, because, you know, it's so beautiful. You just look at it and you see it's symmetric, or it's got a form to it, right? So you say, well, I can do it better, but I'm going to have to introduce a kludgy hack, right? So it's going to spoil the aesthetics and give me like 10 machine cycles better. And then you think, well, okay, well, in that case, most likely the original designer probably thought of that already. And they didn't do it this way because they wanted the aesthetics more than the 10% improvement in performance, right? So you think of all that, and then your life is consumed by a series of flashes of appreciation, right? And you say, oh my gosh, this is amazing, this is amazing, this is amazing. These are things that I would have, you know, spent ages trying to solve. And that marks the onset of a period of humility, right? And you say, well, I'm not this tiger anymore, or a lion anymore, who came out of my cave and said, oh, here's this entire forest and jungle for me to conquer. I'm going to go out there and slap every beast on its face, you know, and say, hey, kneel down, you know, kneel, give me your knee, all right? Bend the knee before. No, that's not going to work, right? The only way it'll work is because, you know, I see all these great people before me, and I say, you're great, I wish I can do something as great as you are, right? And they say, well, at this point, the giant says, right, now, I know that you're not after the wrong thing, because when you enter a field trying to achieve greatness, you will never achieve greatness. I can guarantee that, right? If you do that in the future, and come and let me know, I'll be glad to be corrected there. Because when you're achieving greatness, or when you're trying to do something great, if greatness is your objective, right? Fame and fortune and anything else that you want, those are all wrong objectives, because you're not really trying to achieve greatness. You're trying to achieve fame. You're trying to achieve greatness. You're trying to achieve fortune. You're trying to achieve, people that come to you and say, hey, what a great thing you did. Facebook, 5,000 likes on Facebook. That's what you're trying to do, right? Then you're being pulled off. You're not going in that direction. That's where greatness lies. That's where you can benefit humanity, change the world, make everybody happier. That's what you want to do. Right? Because by making everybody happier, you're going to make yourself happier. But that's what you really want to do, but you got sidetracked. You got pulled to the side by mortal pleasures. Mortal pleasure meaning fame, fortune, those are fleeting pleasures. They'll come and go. But you got sidetracked, you're doing something else. And so you say, and the giant will say to you, well, okay, so you're not after me anymore. You're not after the wrong goal. The wrong goal is trying to say, I'm going to be the king of the world, right? I'm going to be the king. All these giants bow down before me because I'm going to be. That's the wrong goal. You're never going to stand on the shoulders of any giant who you're going to ask to kneel before you, right? The only way you can stand on the shoulder of a giant is by telling the giant, hey, giant, this is amazing. Right? I'd like to take what you've done and give it a new coat of paint, right? Or take that to the next level so that more people can see what you've done, right? And you've done some really. So when you say that, regardless of whether it's Einstein or Newton or Steve Jobs, whoever it is, right? So they will say, oh, well, you're trying to do the right thing, and I'm trying to do the right thing too. Let's do it together. So I've done everything I can, and I think that you're at the right stage of life to take that to the next level. Here you go. Let me put you on my shoulder. You can take a better look. Right? Now go ahead and do that. So that's the way. And then when you do that, you get. So now you're not that roaring tiger anymore. Right? Now you become a humble mouse. Right? As a mouse. You say, then a mouse would say, I'm not seeking greatness. I just want to toil. But I'm not trying to go any new place. You look at a mouse, the mouse is not trying to go and slap a cat on its face. It knows, it listens to other mice that have told it, don't go that way. There's a cat hiding in behind the door. So it listens. It's not foolhardy. I said, I'm going to strike out my own path. I'm going to walk into the cat's mouth and come out alive. It doesn't do stupid things like that. It listens because it pays attention to other great people, other great minds before it. So humble, and then you can do great things because then the whole universe is yours. You just explore, and in the process of exploring, you'll find out. And that's what I find. Most of the time, greatness or making a change is available to every single one of us. The only reason I think, it's a hypothesis, you can test it out, that most people don't change the world is because if they were given a chance to do it, they would have done it, except they got tempted and pulled in the wrong directions off course many times, right? So when they're not going straight forward and say, hey, if you do this, you'll get a lot of money. If you do this, you'll get a lot of fame. If you do this, you'll get that date with that hot person you were, all those things, right? So those are incorrect. It's good, you can get all those if they're byproducts of what you want to do. But if you go in the direction of, that's what I want to do, then you've lost sight of what you want to do, right? Maybe you'll do something, but it's not going to be what you originally wanted. Does that make sense? Okay, so I think that's really the goal of all of this we're trying to do. And when you do object-oriented programming, so this is basically it. So when you have this instance variable and a class variable, you think of, this is the way that the master programmers of those days, if I have a better way to do this, maybe I'll suggest that in the forums. Go participate in the C++ standards and say, or language standards, right? Python, there's so many languages. C++ is because it's older, it has greater inertia. Meaning that if you want to propose a change to the standard, you got to wait longer for it to go through many consortiums and meetings and discussions, and eventually they say, all right, we'll incorporate that into the language after. And believe it or not, this is actually, it's good that it happens this way. When a language is mature and stable enough, like C++, you don't want to futz with it frequently, right? Every morning when I have a cup of coffee, I want to change how string is, how the interface for string. That doesn't work. This language will die, right? So when a language is stable enough, okay, it has a great deal of inertia for good reason, because you don't want to break it. And the same thing with Foothill and all these great institutions, right? So sometimes I get frustrated because we have some really good ideas at Foothill, right? And curriculum. We say this needs to be introduced. This is the way we should evaluate students, right? And because the previous way of evaluating students is a lot of plagiarism, people are copying, and students are passing with A pluses even though they didn't do any work. So let's introduce a new way of evaluating students, right? And maybe those are really clever ways, but then even though they're clever ways, it's not like agile companies in Silicon Valley, right? Facebook used to be famous for saying, break things fast and move things fast, or something like that. In the early days of Facebook, they had that saying, right? The goal was to break things. Meaning, go ahead and experiment and keep breaking, because only by breaking you'll find all the faults and bugs and you fix them, right? So you can afford to do that in the early stages when you're young, as a company, as a product, as a person. You can afford to move fast and break things. But when you're stable and old, it's not so good to do that, and that's why when we discuss these really cool ideas for student evaluation, places like Foothill tried and tested and withstood the test of time. When you have these brilliant ideas for new ways of doing things, it'll go through a series of meetings, and I found that people that are not used to the way things function in stable organizations, right? Not young ones, stable organizations often get frustrated, saying, I have this really cool idea, I want to get this done, but these people are standing in my way because it's endless meetings, 10 people have to approve this, and I got to defend this idea to 15 other people, and shit like that. People get frustrated. But there's a good reason for that, right? Just imagine how it would be if you're programming in C++, which is supposed to be a stable language, and then tomorrow morning your program doesn't compile because the standard changed, because someone incorporated a cool idea. But however, that's still possible in some of the newer languages, right? In Python is still, every day some new changes are happening to 3.78, whatever it is. So there are languages out there, Go, and new features that are being incorporated into, injecting yourself into those efforts, and you can do all those things. So anyway, in C++, so the designer said, I'll place thermostats and switches here, right? So that's marked on the blueprint, because the builder has to follow the blueprint and place those controls exactly there in the actual house. Yeah. Now imagine if the builder, someone passed by and said, hey, Google went by the Apple building and said, hey, that's really cool, I want to build something like that, and they contracted the same architect. They said, I want to buy the exact same plans, and I want to build the exact same building, except that in Google, our engineers like to work not at 27 degrees Celsius, but 28 degrees Celsius. So all the the thermostats have to be placed here, or maybe Amazon, right? Because they have a rainforest inside their office, so they have different controls in different places. So they'll say, all right, do this, place, right? So the builder would say, well, I'm going to use the same plan, but I will place these units elsewhere. So you have two different buildings built off the same blueprint, right? Same blueprint, two buildings, but they have slight differences, right? And what are the differences? Thermostats are in different places, switches are in different places, but they're the same blueprint. However, they also share the same features, right? The features are the defining features of the blueprint, right? This is the overall shape. These are where the doors are, the rooms are, and so on and so forth. So there's the individual features, and there's class features. Okay, so these class features, or class variables, they're called static variables. This is a class variable. You stick them on the blueprint itself. So the blueprint will have a variable in there saying number of thermostats equals 47. Okay, so that belongs to the blueprint. Whereas, oh, actually, it's not the. Let's say. Yeah, okay. Maybe that's fixed, right? The architect said you can't move the thermostats around. This is the exact number of thermostats. This is where it's going to be, right? You can't change those. If you change those, the building is going to look different. So, but the builder might say, well, you know, I'm going to change the temperature setting on all the thermostats in the Amazon building, right? So default is different. So how could you have two different objects made by the same blueprint differ in these details? You do that by saying that not only do these two objects share the bulk of their structure, right? Most of the variables are shared, but there are a few that are specific to each instance that was built from that blueprint, okay? Those are called instance variables because you can change those variables on a per instance basis, right? You can change the thermostat setting in my home and not change the setting in Jessica's home, for example, right? Because they're two different homes. Maybe they're built from the same blueprint, but they're two different ones, right? So they're instance variables. However, if I had, let's say in the future we had a blueprint for a reconfigurable home, right? It's not unimaginable, right? You could have, today you have apps that you can reconfigure. You know, Facebook doesn't let you do that, but you know, there's MySpace, right? You can have an app and say, I don't like my home, I'm going to paint it, you know, I'm going to reconfigure it. You can reconfigure how your app looks, right? There's all these configuration options. Maybe in the future, you'd have a home built of intelligent particles, or intelligent or nanoparticles or something like that, and you configure your home on the phone, right? And say, and step out of the home before you reconfigure it, okay? And you hit a button, and then wait for 10 or 15 seconds while your room, you know, all the particles that make up your home basically just reshuffle themselves, and then you go into a brand new home, you know, reconfigured, or repaint it. So it's not inconceivable. You know, scientifically it's possible, right? So in that case, then you've changed the entire blueprint. Or maybe you take your home and say, well, I don't need this blueprint. You change fundamental characteristics. Then the blueprint is changed. It's a completely different object. But if you have the same object, you can have multiple instances of the same object, but they could still have different properties. So then you have instance variables and class variables. Okay, so the best way to understand how these work is, actually, has anybody, I know a couple of people are on quest number 9. What about quest number 6? Does quest number 6 have a population static variable?
Yeah.
It does. And is it part of the mini quest too? You actually have to change them?
Yeah.
Okay, all right, good. Yeah. I forgot whether I put it in. Because a static variable is a variable that's attached to the class template itself. It's in the blueprint. It's not, so everybody doesn't get a share. It's not one variable that's shared by all the people. Right? Suppose I, you know, on the blueprint, if I scribble something on the blueprint, that's a class variable, and then a builder takes that, makes a home with that blueprint, and then if she goes ahead and rubs off my name on the blueprint and puts her name on it, then the class variable, anybody who takes that blueprint from then on would have a different, you know, that variable. So anything that's scribbled on the blueprint is a class variable. Anything that's scribbled on the wall of your home is an instance variable. Is that a good mnemonic to remember? Yeah? Just remember a home and a blueprint. If it's on the blueprint, it's a class variable. So if you change that, everybody who has the same blueprint has the new variable now. But if you change it in your home, then other homes of the same blueprint won't see that change. That is the greatest advantage, or you know, difference, the greatest difference that you can leverage between instance variables and class variables. So today what we can do is let's create a class. It doesn't have to be the pet class. Don't work on the Western class, okay? Do something else. Let's create another class here. Someone give me a class other than pet, you know, some object. A student class, employee, this is routine, boring things. Animal. No, the animal is just like a pet. Something else. Tree, okay, different kinds of trees? Yeah, okay, all right. So Christopher says tree. So if you can't come up with your own class, object, class and object, use tree. I just want one as a backup default, right? You don't have to do tree, but if I said, everybody pick your own class, then you'll probably spend 10 minutes thinking of your class, right? So we got a tree, that's your backup, and that's Christopher's class. So if you can't come up with your own, do a tree. The only constraint is that your class should have instance variables, which means these are variables that are particular to that particular instance, like the number of leaves. The number of leaves is an instance property. Because I have two trees that are both, elm trees, two elm trees, right? But one has 20,000 leaves, another one has 25,000 leaves, right? So the number of leaves is a property of the instance, whereas type of tree, right? Elm. Well, even that I can imagine to be a class, an instance variable, but you can imagine, right? Something else. Total number of trees in the world. Right? That's like a population. But you can imagine, you can come up with something, right? Something that belongs to the whole. Because one thing that belongs to everybody, and one thing that belongs to each person, right? So the thing that belongs to everybody should be the static variable, the class variable. Let's get that going first, and then after that we'll talk about scoping and visibility. Because once you have visibility of items inside of a class, we'll talk about the greatest advantage of object-oriented programming, right? Technically, ideally, that's what I should have spoken about first, because that's the most exciting thing. The greatest value from object-oriented programming is really the ability, the power to design a class that's really a container, right? And put a lot of stuff inside of it that only you can see, other people cannot see, right? And that is a power. That's a power of that's classes for object-oriented, right? Because once you create something which requires a lot of stuff to do its job, right? Maybe it's a really complex object, like a house. A house is a really complex object, right? So it has lots of things. You got to get, electricians and plumbers, and so it's a really complex object. Yeah, so you can do that. I don't know how I got started talking about that. So yeah, you can build an object like that. Yeah, select an object. Yeah, all right. Hiding, right? So you got this object, and then you can say, well, and here's the goal. Why do we want objects, right? So you don't need object-oriented programming, let's say, to construct your complex object like this. But the real value and the power of an object-oriented comes out when you say, I've built this complex object, and in order for you to use my home, you don't have to understand how I built it. So that one sentence that I just said is the power of object-oriented design, right? Forget about programming, object-oriented design. So if I build a house, and I say, every house I build is going to have a door and a front yard that faces the sidewalk, right? So I just say that and say, every house I do, that's what it's going to do. That's what it's going to have. Meaning, I provide that contract to the Palo Alto City Council. Well, the City Council tells me, right, that's the only kind of house you can build, or something like that, right? So you say, that's my contract, and then the City Council will tell you, all right, as long as you stick to the contract, you're fine to build any kind of house you want, right? All you have to do, this is the contract between you as a citizen of Santa Clara and us as the governors of Santa Clara, is that we want you to be happy. We want you to have a fulfilling life. We want you to be able to do everything you want, as long as you're not a nuisance, right? If you're a nuisance, then we'll look into, how we can curtail your freedom. But if you're not a nuisance, if you just want to be happy and make others happy, knock yourself out, right? So they say, if you want to build a house, build a house as nicely as you want, except that we have a few, not too many, 10 conditions you got to fulfill, right? You can't build a house more than 3 stories, because 3 stories means you can climb up there and look over the fence into your neighbor's window, right? So there's privacy issues. Or you can't do this, or you got to have a sidewalk, 6 feet away from the road, or things like that. So they give you this list of conditions. As long as you abide by those conditions, you can be a helpful and good citizen of this county. So like that, once I have that freedom, I know what I'm allowed to do. With that, people always say, with object-oriented programming. Oh no, when I do this, when I have all these rules, right? I live in a democracy and I have to follow all these rules. It's restrictive, right? And that's really a pessimistic view, because you're looking at what's not possible. Right? You get given a glass and you say, oh, it's half empty. But the right perspective is to say, what do I get in return for observing these rules? Which I couldn't have got without. So if I told the city council of Santa Clara, no, I'm not going to abide by your rules. I'm going to build my house any way I want. I'm going to build my house right on the 6 feet clearance between my home and the road. I'm not going to respect that. I'm going to build a home that step right into the streets, right? And that's really, I'm shooting myself in the foot, right? Because I've given up my right for being saved by the city council's rule that says, don't do that, because if you do that, you step out your home and a car could run over you, right? So it's sensible guidelines. And so they say, and so if I interpret the rules with that perspective, see, this is exactly the same rule. When you're looking at two different perspectives, right? I'm saying this rule is restricting me. Obi-Wan Kenobi is saying, don't do that. He's holding me back, right? Anakin is complaining, but you're looking at it that way. But exactly the same, right? Obi-Wan is not going away. He's still saying, don't do that, don't do that. But all Anakin needs to do is just say, all right, let me just shift perspective from here to think about why he's saying that, right? You say, meaning, let me look at why he's saying that instead of imputing an ulterior motive to that person. Because, if you look at the movie, that's what he says, right? He's complaining to Natalie Portman, saying, oh, he's always holding me back. He doesn't want me to become greater than he is, right? But did Obi-Wan ever say that, oh, I don't want Anakin to be greater than I am, so I'm going to hold him back? He never said that. So where did Anakin's hypothesis, really it's a hypothesis, that Obi-Wan is holding him back? He never said that. Where did that come from? Where did that hypothesis come from? The only place it could have come from is from himself. So he created the hypothesis of this ulterior motive that he imputed to Obi-Wan. Yes? I don't see that in the movie. So that ulterior motive didn't come from Obi-Wan, it came from you. So if Anakin had switched perspectives instead, and said, instead of thinking about what the rules are, from the perspective of this ulterior motive, which didn't exist because it's fake. I'm just going to say that's fake. I'm not going to look at it through that lens. I'll look at it for what it is, right? Through the right lens. Then you see, wow, that's why the rule is in there. The rule is in there because if I didn't follow those rules, I'd be dead tomorrow, and I wouldn't have a chance to show the world how much more I can do. Right? So if you look at it from that perspective, then you look at all these restrictions in object-oriented programming and say, well, why are these restrictions in place? Why can't I go and fiddle with these 1,000 variables inside a string class? So if I do that, then 90% of my time as a programmer, as a creator, will be spent in fiddling around saying, why doesn't the string class work as it is supposed to do? Right? Because I went in and fiddled with it and broke it. The developer of the string class said, here's a class for you to use. It can do marvelous things for you. Just don't fiddle with it too much, right? Don't mess around with its internals. As long as you don't mess around with the internals, it'll do exactly what you want it to do. Then if I have that kind of assurance, right, from the developer, that basically frees up 99% of my mental cycles. Then I don't have to waste my mental cycles. I don't have to waste my time thinking about, oh, is this how I'm supposed to do it, to get around. That's a waste of time, right? And so you say, well, now I'm just freed up. No, C++ string told me, has given me this freedom to say, you know what, you are capable of so many great things. I don't want you to be futzing around with these low-level shit. That's really what C++ string is saying. That's what object-oriented programming tells you, right? OO tells you, you are capable of great things. I don't want you to be wasting your time futzing around with little details that a machine can do for you. So we're the machines. We'll create the string class. We'll create this. We'll create that. We'll give you all these enablers. Take that, put them together, and that's your greatness. So if you look at it that way, then you look at, all those restrictions in democracy. You say, don't do this. You say, well, I follow rules in democracy because it frees me up from the worry of being able to, or worry of constantly watching my back, right? Imagine if you're living in a jungle where there's, snakes and tigers and cats, all, are always looking to get you, right? You don't have a moment for creativity. Well, you maybe have a moment for creativity when you go in your cave and block at the boulder and thinking in a candle, in a fire. But a lot of your time is wasted in just being, safe, right? So democracy says, no, we'll take care of your safety, but just follow these rules. As long as everybody follows these rules, you have an immense amount of freedom and time to think about what you can do. And when you can think about what you can do without having to worry, you will be totally amazed at what you're capable of. Most people don't know that because they're constantly worrying. They're constantly worrying about, how do I do this? What does that person think of me? How can I get $1 million? How can I achieve that? When you think about that, that many machine cycles gone for those things, right? Whereas, and you'd be surprised, you may think that, I only think about other people thinking about me for 10% of my life, right? You might think, 10% of every day I think about what other people are thinking about me. But it's not 10%. You'd be surprised, right? Because if you sit down calmly and reflect, quietly for an hour, you'll see that you may think that 10% of your time is consciously thinking about what other people are thinking about you, but subconsciously it pervades your thought all the time. All the time, everything you do subconsciously is being filtered by that layer on top that says, you think you want to do this, but really, that conflicts with your other goal of wanting to impress that girl or impress that woman, or making $1 million, or to ace that interview and make that interviewer think that you are better than that person. So all those thoughts basically subconsciously stifle a great deal of creativity. So you got to get used to that and understand that you don't have to worry about those things. Just start appreciating the rules rather than begrudging or bemoaning these rules. And once you start appreciating someone, then miraculously you'll see the value pour out of that towards you, right? And you say, oh my gosh, there's so much more available to me. So once you start appreciating what Foothill gives you, instead of, fortunately at Foothill we have this, incredibly good fortune that students usually don't complain about because many students are, partly because it's so cool and nice and beautiful out here, but people don't complain. But I've seen, many schools and colleges where students are always complaining. Even though the colleges offer so many things to the students, they complain, right? The problem is, once you start complaining, you subconsciously, I think, again, it's a hypothesis, you stop seeing the good things about the person or the entity you're complaining about, right? Because once you complain, I think it's like you have a hypothesis saying that entity is bad. And anytime a human being has a hypothesis, there is this hypothesis, this bias. So I somehow I need to make sure my hypothesis is true, because everybody wants to feel right? True. So if I say something, I don't want to be wrong. So I'm going to be looking for all the things out there that corroborate what I say, rather than look at things that dispute and disprove what I say. So I'm going to be looking for, so even if Foothill comes to me and says, as a student, right? Oh, you can have free food here. You can have free books. You can have, you can talk to this person who knows this thing. I'm going to say, no, I've done that in the past, never works. You're just trying to get me, right? So you look at all the bad things and not the good things. Because why do you do that? We always try to corroborate our hypothesis because our desire to be right is stronger than our desire to do right. So we want to. So I think that's the thing. And once you get past that, I think it took me a long time. It took me a very long time to get there. But hopefully you guys will get there sooner, and then you'll be able to just change the world. All right, so go ahead. We got an entire hour. You can open up your laptops, create a class. We'll talk about scoping and private and public next class, okay? Because I think that ties in more to the methods. Forget about the methods now. We'll implement the methods. We'll implement getters and setters today, right? And the static variables. Okay, so implement your class. I'll come around and take a look. Do it in groups if you want. So you should implement a class. It should have a bunch of static variables and, maybe one static variable and a bunch of instance variables. And for each of the instance variables, you need to provide a getter and a setter. If you don't know what they are, you can ask. One of your classmates will help, or I can help. Right? A getter and a setter. A getter is something. Why do you need getters and setters? Because you have properties. Each instance has properties, right? So, but you can't see these properties from outside because I've hidden them away. I've hidden away the properties. How many leaves do you have? If I have this tree here, right? It has a bunch of leaves, but the number of leaves is a private property. I can see if I can it, right? So, but if I want it, because it's private, the only way I can get the property is by asking the object. Hey, dear object, how many leaves do you have? Right? It will tell me, right? Because it goes inside, counts the leaves, and tells me. And once you have hiding, it's important to also have the right level of surfacing. So you've taken a whole lot of stuff, hidden it away from the user, and then only surface the stuff that is necessary for the for the work to be done. Now, you'll be surprised. This is not just object-oriented programming strategy, but later on, when you go ahead and architect big systems in the cloud, right? In the cloud, or massive systems, interlinking with 5 or 10 different AI, machine learning-based systems, you tying them all together, wiring them to create a beautiful app. When you're doing that, you'll find that. How did we start talking about this? Getters and setters. Yeah. Okay, thank you, Jack. So when you do that, you'll see that it's got all these complex systems in there, but I still need to get inside to get a few things, right? So you'd say, I've got this, and these are the only things. Yeah, okay. Right. So when you design these complex systems, you'll find that one of the easiest strategies to designing these big complex systems is to basically say, let's take permissions, right? User permissions. For you have these big systems, each with a lot of things that you can access, and then a user is going to come in, access your app, which is going to access these big systems out there. And you want to secure your system and make sure people can't hack into it or something like that. So one of the best ways to do it is to say, I'm going to close off all doors, right? And say there's no access to anything inside my system. Do that. And then you'll find your system doesn't work. Yes? Good. Because you don't want it to work when you close the doors. That's your first test. Because when you close the door and people are still able to access your system, something is wrong. Okay? So that is, obliterate all permissions. And then start giving out permissions little by little, just to make sure your work, each thing is able to do exactly what it's able to do, but nothing more. And you do that little by little until your whole system works, and stop there. Right? You don't give out any more permissions. Now, the reason for doing that is not just because you want to safeguard your intellectual property or keep it all hidden away. It's really because you're enabling other people to take what you build and build on top of that an even higher dome. Right? That's how the Statue of Liberty, not the Statue of Liberty, the Empire State Building won the competition. You know the story? Because in New York, apparently there was this competition to build the tallest skyscraper, and there was another building, the Chrysler building, I think, next to the Empire State Building. It was rising up at the same time. They were competing with each other. But then the architect of the Empire State Building said, well, we got to win this competition somehow, so let's build this big spire. But we'll build it inside of the building so nobody can see. And then on D-Day, when we have to demo our buildings, we'll just raise that spire, make the Empire State Building like 200 feet higher than the Chrysler Building. And that's the story. I don't know if it's true. Okay, like that. So hide it and then expose it only at the last minute because you just need it for that one thing. And that's the way to build secure systems. It's not just security, right? If you build a complex object-oriented system, that's a good design practice. Keep everything private until it absolutely needs to be public. But if it's private, how do I get at it? So when you decide to expose it, don't make it public, but give it a getter. Meaning that every time you want to expose a property of the instance, don't expose the property directly, but employ a manager. That is your getter, right? The manager knows how to go into your home, right, into that object, grab what is needed, and give it to the person who is asking, right? So every property that you want to expose to the outside world has an outside-facing endpoint or a manager that knows how to get it and give it out. That's called a getter. What if someone wants to say, I want to change some property? You can have explicit fine-grained control. You don't have to have a single method that does both getting and changing the value. You can have two different methods. You can knock yourself out. You can have a million methods for doing tiny changes to your property, right? You can have a real value variable. You can have a setter that sets the value from 0 to 1, right? Another setter that sets the value if the value is from 2 to 3. But all of that just makes your code more complex. So at a bare minimum, I think most designs have a getter and a setter. So two managers. One of them is going to get the value and return it to the caller. Another one is going to take the value from the caller and put it in there. The advantage is that this getter guy, this manager, is not employed by the outside party, it's employed by you. So that person, that manager, the getter, only listens to you. And therefore you have full control over what that person can look at inside your object, right? It's like, just like you have security personnel in big companies, right? So if you want to know if something works in a big company, you go and ask that person. You can't go and check it yourself. They'll go and check it and tell you, right? Like that. Those are your getters and setters. That is your interface. So for that reason, getters, setters, all these methods that are public, anything that's public, private, nobody can see. Public, everybody can see, right? So these public methods, they're called an interface, right? It's an interface because interfaces between the internal, that's your class, the object, and the external worlds, right? Inside your object and outside the object, the interface. So when you have such an interface between an object that's your entire application, this interface is called an application programming interface, right? Because you can program this application by hitting the interface which the designer of the application has been kind enough to provide to you. So that is called an API, right? An API, I mean, people talk about APIs, right, all the time. So all these fancy web services out there and say, oh, it's got this API. That's all it is. An API is basically a bunch of public methods that people basically expose, right? And the beauty of an API is that it says, rather than, so when you read an API and these guidelines, don't read it as saying, oh, this API lets you perform only these actions on this class, right? No, that's the wrong way to look at it, right? You read it as saying, oh, this API takes care of a whole lot of things for you. These are the only things you need to handle. That's the way to look at it, right? So, as parents and children, and that's also a good perspective, right? So don't look at parents as saying, well, my parents have to provide all these things for me. No, or teachers have to provide these, oh, Anand didn't teach me about this. You were supposed to teach these things, you didn't teach. Or Anand said, don't do this, right? Don't work on quests in class. Don't do this in class, right? Or your parents might have 100 restrictions. Don't get stoned and walk onto the door, in front of a car. Good sense advice like that. And don't look at those as restrictions. But if you look at them with just a different lens, just like it's a different lens, and say, they're not trying to get you, just trying to say, we'll take care of everything else for you, take care of this. We'll take care of your food, we'll take care of your lodging, we'll give you everything you want, we'll give you encouragement. We'll, if your instructor wants to meet me and talk to me, I'll come and talk to them. I'll give you everything you want, but I cannot take care of you going onto the road not sober, right? I can't take care of you when you're driving drunk. So please take care of that, and I'll take care of everything else. So exactly the same thing, but a different lens. And I think when people look at things with the wrong lens, they look at it as a restriction, as people trying to, suppress them and say, don't do that, don't do that. Look at it with this lens and say, you're free to do this because I can take care of all of those. And then you can say, wow, I'm free to do this, I'm free to do this, okay, I'm going to do this. You do everything. So then you can knock yourself out, because otherwise you spend a lot of time just trying to break through everything that you're not supposed to do. And what's the pride in that, right? What people say, oh, I hacked through the system, I hacked this system at NSA, I got into the Pentagon and exposed their secrets. You know, that's a crazy load of shit, really, if you ask me. Those protections are there for a good reason. Why did you waste all your precious intellectual resources, the same resources that you could have put into changing the world? Why did you have to waste those, right? So as a child, why do you have to waste your time complaining about your parents rather than saying, my parents have given me so much, I don't have to worry about those, I don't have to think about those, they've freed up my time to go ahead and play in a risk-free environment, right? You know, don't do insensible things, you know, nonsensical. Then you can do great things. That's what it is. All right, okay, so go ahead. And by the way, you can code even when I'm talking, right? Only when the time I'm talking about objects and instances, those are the times you need to listen to me. Other times, I'm just talking. You can do your own stuff. Call me, okay? If you need my help, call me. If you're stuck, call me. Hey, Luke, are you okay? Are you working on a class? Okay, so I'll come around. You guys got to tell me what class you're doing, what class you're implementing, what you're doing. And if you're doing something really interesting, please volunteer to come up here and demo. Okay? You can't imagine how much the online students are looking forward to some of your videos, right? In class, fellow students, not from me. This is useless. If I do a video and post it, it's just like a lecture. The online students don't care about that, right? Because they can read a book. They can read a text and they can get the same modules. But if you come up here and oh, hey, that's Jessica. I talked to her in the forums and she, helped me with quest number 3. Let's see what what her project is, right? They'll actually look at it and they'll learn something from it. So you should totally not feel shy, or even if it's an error. If you've got a bug, we'll debug it together. That's even better. The online students will think, hey, it's not just me. Everybody has the same bug, right? So I think that's much better. Everybody has to know that it's okay to make mistakes. And that's the greatest problem, I think, with first-year students anyway. Okay? As you get to my 2B and 2C, I think you'll get more comfortable with making mistakes. But for 2A, it's bad, mainly because there's such a variance, especially in community college. Not so bad in I think in UCs where already they're doing this filtering. You got to have some SAT score and stuff like that. So they have less variance between the students. But in community colleges, we just say first of all, it's so cheap that anyone who wants an education can come and get it, right? So it's so cheap, so like $70 a unit or something like that, correct? So, right? And in fact, if you can't pay the fees, you just go and ask, and there are people here who can just help you and say, you don't have to pay the fees, come and attend classes, right? So, I mean, the scholarships and so much money. So, you can take advantage of these things and make mistakes. And the first years, because this is variance, students are so scared to come up here, and they think, oh no, if I go there and say the wrong thing, all my classmates who are coding up the next iPhone, right? They'll think I'm stupid. But by the time you're in 2B, you would have demoed so much, you would have made so many mistakes, you would have failed so many times, and you would have seen me fail so many times, right? And you'd be comfortable enough with failing. Say, hey, even Anand has so many bugs in his code, right? So I'm perfectly comfortable having bugs in my code. You got to be comfortable. Yeah, be comfortable making mistakes. In my experience, the best way to get comfortable making mistakes is to say, never identify yourself with the mistake. Right? If you say that I'm the one who made the mistake, well, if you say that's me, then you say, okay, that mistake has got to live with me, right? But rather have the perspective that I did something yesterday and now I know it's wrong. Oh, so that's not the right way to do it. I'll do it differently from now on, right? Then that mistake is not part of you. It was just something you did. Now you know not to do it that way, right? And then you know how to do it the right way. So then that mistake hasn't affected you or the quality of your work or you as a person, right? You're separate. You're just using all these tools and learning how to use those tools. Sometimes you don't know the best way to do it. You look it up online. You have a question, Taylor?
Yeah, it's about my code.
A question with your code?
Yeah.
Okay, I'll come around. Okay, all right, guys, go ahead and do it.